ready to stream. Started it up in my recording profile. I'm sure that all of you wanted to see that in low frame rate Synco Vision, but now we're live in my streaming settings, which should be a lot better for 99.99% of my viewers. Also, you'll be able to hear both audio tracks. I know that that's critical when you're listening to someone program. Alright, so today we're going to be working mostly on UI, but before we get started, I should probably tell the world that I am streaming. Some of you are already here. Eva Luigi and TechCure95 are both really on the ball. I'm going to go ahead and post to any various social network I can find that now I am streaming. I am streaming some game dev, gonna be some relaxing UI stuff. Paste. Close that down, paste. Yay! Alright. Let's switch this out so that I don't get any RAM loss in the background there as Twitter eats it. Perfect. I may be a little bit wheezy on the channel today because it's really bad outside today. So even a little bit of exertion will get my asthma going, and I ran home. So I hope you appreciate the sacrifices I made to stream at mid-afternoon in Boston time. Okay, so I released a new version of the game, and if you guys haven't played it yet, you should. There should be a link somewhere on my channel. If you can't find that link, let me know, and I will try and figure out where to put it. But there's a new version of the prototype, and you can go and play it. Or you can watch me fuss around with it if you don't feel like it. So what we've got here is a situation like... Oh, you'll have to tell me how good the audio is, because I think you can hear the music now, and I'm not sure how loud that is. It might be too loud. Let me bring it down another couple of decibels. So you may have noticed that this UI is pretty crappy. Today we're going to try and make the ship system UI work a little bit better, by which I mean the construction here. Right now, in order to move parts around, you click on them, but then in order to do things like rotate them and stuff, you use shift, and that's just awful. And to move things up and down, you use control. That's also just awful, especially for me, where control is hijacked by Unity. So, let me just ask, can everybody hear me? So what we're going to do instead is, you see this highlight here? When you right-click to highlight an item, what we're going to do is we're going to have that create a rotational element that'll let us rotate and move our editing system around. And that's going to require us to add in some new UI elements. So we're going to just go ahead and do that. Let's grab our... just a prefab for the sake of having something on the screen we can look at. Like, say, the fuel cell. That'll do. This is a fairly small object, but what we'll do is we will scale the system by the size of the bounding box. And since nobody has responded to either me talking or me typing, whether they can hear me or not, maybe nobody can hear me. I'm never sure with Twitch. Would someone please tell me whether or not I am audible to them? Because OBS says I am, but I've had problems in the past. Yes, thank you for randomly popping something up at the bottom of my screen. Super helpful. God damn it! There is a limit to how much annoyance Windows 10 can... I don't even know if you guys can see that. To you guys, I might just be complaining about something that isn't even on the screen. But I'm getting these giant pop-up tooltips. Tikir says he can hear me, so I guess that's good enough. If one person can hear me, everybody can hear me everywhere across the world. I have 7.9 billion viewers. Right. Asset time. We're going to do this in world space rather than in screen space for passably obvious reasons. And what we're going to need to do is create some objects. And for now, we're going to drop them into the fuel cell just to get ourselves sorted. And then what we're going to do is type in a name for them. We'll call this the widget space ship module widget. And this will be what will allow us to do all of our ship module stuff. And in it, we will put a quad. And we'll make that quad nice and big, like 5 by 5 by 5. Let's see, probably has to be even bigger than that. We're going to need a new material, so let's go over to the materials and create a new one. We've got a variety of holographic materials. We're going to go ahead and create a new one here. This will be our hologram ship module edit. We're going to use a different texture for it. So first off, we'll drop it under the quad. And now we're going to change our texture because I got a new texture. I made it just a second ago. And it is the ring here. I have a better ring than that one. What did I call it? Big ring. It's just white on white in the preview. Brilliant! Boom. And we're not going to do any tiling at all. Like so. And there won't be anything down here. Perfect. We don't need any of this stuff. But we should be able to see it, and I don't. Aha, so it's not a two-directional thing. That is annoying. I would like this to be two-directional without any sort of backplane clipping. But in order to do that, I have to create a custom widget. I have to create a custom, not widget, material, like one of these shaders. Thank you, Craig, wake up. So let's go ahead and create ourselves a custom shader. It's going to be very, very basic. It's going to be our in-world UI shader. We can do it in a couple of different ways, but since we are going to be doing something that shouldn't react to light, we'll make it unlit. And we'll go ahead and stick it into our materials. And we will call this the 3D UI. There we are. Boom. So we've got obviously a color option here, which is just going to go straight into our emission channel. We're going to have to test that and see whether that's what we want. But we definitely want our texture to be in this mess. So let's bring in the texture here. Oh, that is not a T, that's a V. There it is, texture. So I'll call this texture. And our texture will definitely be defining our opacity or our opacity clip. Now, if I do opacity, we're going to have problems with Z-fighting. If I do opacity clip, we're going to have problems with aggressive edges. We'll go ahead and leave it with the problems with aggressive edges for now. But it's always best to put in a value adjustment, so we're going to do that. And this will be called the clip adjust. And we're going to add in some arithmetic, because everybody likes arithmetic. And we'll just make this go here, and this go in here, and this go in here. And that way we can create ourselves a nice little opacity. One of the things we can also do is we can choose to create an outline. And I'm not 100% sure that we're going to want that or not, but it's worth doing. And we will make this outline color equal to black, I guess. Color. So this will be outline width, and this will be outline color. And actually, there's no reason to even have an outline width, because we can just use our alpha channel. So outline width and outline color. Boom. So right now, we do not have this texture hooked up to our emission. So that's what we're going to do. We're going to just go ahead and multiply them together using a typical multiply. Boom. That should be all we need, but there are a couple of shader settings we need to edit because we need to turn off backplane culling. One of these is backplane culling. It's in here somewhere. Here it is. Double-sided. Perfect. Thank you. Compile that shader for me. And now let's take a look at how it looks on the screen by switching over to our new shader. Boom. Oh no! our opacity is not quite working. Oh, we don't have the texture went away. That's why. Just drop it in. There, perfect. And now you can see that from both sides we have the same object. I'm a little bit confused as to what the heck that was out there in the front. That was weird. You know what? Let's just draw this all away for the moment, because it's kind of in the middle of this mess that we've built, and I don't particularly need it to be. That'll do. So I've got this issue here where we've got this random floating plane, and I don't know what it is. This quad here should be at 0, 0, 0, and it is at 0, 0, 0, but why is it being drawn over here with a weird shadow? Well, that's super strange. What could that be? Because that's... Oh, there's a bug. Look at this. I switched over to a non-shader forge shader, and it's still malfunctioning. Alright. So here's what it looks like when it's a transparent cutout. You can see that not only does it highlight correctly, but it highlights pretty well. The problem is that we can't color this. It doesn't have a color element. And if we go over here to texture, it doesn't have a color element and it's not transparent. And if we go over here to color, it doesn't have a texture. So all the unlit shaders are really terrible. But when I go over to the 3D UI shader, I don't know what this is. I can't even click on... Okay, that's... I don't like that. We'll leave it for now, but I may have to change that because that is really weird. I presume that that whoever is watching can see what I'm seeing and I'm not just hallucinating. Anyway, we're going to need 2 more of these guys. Boom. We got ourselves a wall of clickable objects. Now, the difficulty with this wall of clickable objects is that it is not going to work. I just spent all that time, and I didn't think it through, and I screwed up. I'm sorry. Oh. We have to make those meshes. So let's go ahead and make those meshes. It's not that hard. Just go and pop up our mesh system. Models, MISC. We'll just add it to this MISC file. Right now it's only got an arrow in it and a great big block. We don't need that block anymore. Well, you'll need the arrow, but we can hide it. We're going to go ahead and create ourselves a circle. Like, yeah, that'll do. And then what we're going to do is add it and then shrink, and that'll do. We'll go ahead and invert those just so that it does point the right way for us. Well, now that we're here, we might as well create this circle pointing both ways. So let's go ahead and point it both ways. You know what? Let's start by... Oh, we can do it. Yeah, we can do it both ways. That's... Sorry, I'm thinking too far ahead because we're just going to go ahead and do an unwrap. And that should get us a nice solid UV. There, perfect circle. See it? And that should line up pretty well with the UV in my that I actually gave. We're gonna go ahead and rename this to a. You know what? Circle is accurate. We'll call it the clickable circle. And what we'll do is we'll just put in like a tiny little nudge here. Perfect. So that ought to do. I think that's the right side, but it might be the wrong side. We'll find out later. So save that and go back over into Unity. That's not Unity, that's Blender. This is Unity. You can tell because it's Unity. So here we've got this mesh filter. It's a quad. We're going to change that over to our clickable circle. Cladding, cube, clickable circle. Boom, like so. Yeah, that little divot I created is on the wrong side. So undo, and then... Doop. I don't know what this is. What's with this wobble? There shouldn't be a wobble there. Alright, fine. No distortion. Let's try that out. I don't know what's up with that wobble. It must just be due to the poor mapping. But now that we have a circle like this, what we can do is we can use the unlit texture. Unfortunately, we can't shade it if we do this. We can't put in a color. It's just this flat white texture. But we could do a standard and put it in as emissive. So if we do our emission map, this can just be black. And then this emission can be whatever color we want it to be, like bright green. Black is probably the wrong idea. White is probably better. Make this darker? No? No? Huh. What if we put that in as our emission map as well? Now it's still barely visible. I really don't need this to be lit at all. Unlit. Transparent. Oh, this one does have a color attached to it as well. Okay. I don't actually need it to be transparent anymore, though, so let's go ahead and try unlit detail. That's obviously not rendering at all. You two can get deleted. Don't need you anymore. There's a mesh collider here, but it's for the wrong mesh, so we'll go ahead and stick that in as a clickable circle as well. What happens if we do a basic outline for it and just make it a toon shader? The toon shader is fundamentally an unlit shader, and I can change the main color like so. It doesn't look too bad. Now, there is no toon cube map, though. I guess it doesn't matter. So if we were to hit play and take a look at that, just to take a gander at how that looks. Where is it? Oh, it's over there. Oh, it's not on the right layer. Hold on. This has to be on our highlight layer. Good, good. So that actually doesn't look too bad. Could look better, but it doesn't look too bad. I can always edit the texture later to try and fix it up. I don't think that there is any point to having an outline on it, though. I thought I would try an outline. Maybe if I have like a white outline. Let's see whether having a white outline is good. Because a black outline obviously doesn't show up very well. Now this white outline is pretty skimpy. You can barely see it. It looks like a dotted line. Is 0.03 the highest you're willing to go? Why is there an artificial limit of 0.03 on the shading width? That's kind of crap. Well, if it's going to be like that, there's not much point to having it as an outline, so we'll go ahead and just go with basic. And we'll edit the texture later to try and make it look better. Hurrah! Alright. So we've got a couple of these quads here. We'll change their name to clickable handles, or just handles. Handle, there's only one of them per object. And then we can duplicate, rotate, and duplicate and rotate. Now, when you click on them, you'll actually be clicking on them. Hurrah! So when we talk about which direction is which, we should generally stick with the same color scheme that Unity has. However, this is not rotated in the same direction. If we take a look here, this has been arbitrarily changed, its rotation. So it's not actually the same angles as Unity itself uses. But this is. So by just looking at which angle it's aligned with, we'll pick the same. Oh, I see. We're gonna need 3 different colors here, huh? I forgot that. I forgot that you couldn't override them quite that easily. Now I could override them like using an animator, but that seems like overkill, really dumb overkill, so we're not going to. We're just going to create 3 different holographic ship module edits. And we'll make one of them 4, I guess. So this one will be X, Y, and Z. So if we take a look here, which direction is this? It's X. So this should probably be the X-axis material, but I have a feeling that's not going to end up lining up. Whereas that is going to be the blue Z-axis material. And then this one will be the Y-axis material. There we go. So with that in mind, let's go ahead and set these up. X is red. It's always been red for some reason, see? And then we got our Y blue here. Z, huh? I guess it doesn't matter which of these is Y and which of these is Z as long as they are unique. But this one is definitely supposed to be blue, whatever it is. So we'll go ahead and do just that. And then this last one is supposed to be green. It may be that we have chosen the wrong directions for these various colors, but that's the basic idea. Now, because they can be clicked, or they can be hit with a raycast, we can actually highlight them when we are in our ship edit system, and that will allow us to interact with these rings instead of with the objects that are connected to them. However, we're going to need some professional help from a script in order to do that. So just double check and see whether I screwed anything up in the background here. No. Nobody cares about a Wednesday stream, so I'm not too disappointed that I've only got 1 viewer, but that's fine. Welcome to 1 viewer. Script. So we're going to want to have another clickable object here, but it's going to have to be a ship module clickable object, which is a special kind of thing that doesn't exist yet. So we've got a ship component. See this? We're going to have a ship component edit widget. So ship component widget editor, or edit widgeter. There we are. It's a long name, but in this sort of case, it's better to have long names that you can't screw up. Okay, come on, finish compiling. Slowpoke. Ship edit widget. Ship edit widget. And ship edit widget. Now the question is, how much of this has to be done with like programming, and how much of it has to be cached here? Do I have to make each of these widgets remember where they're pointed? Or can I just use the fact that they're aligned in a specific way to make it work? And I think I can use the fact that they're aligned in a specific way. We'll have to try it out. So first things first, let's drop this fuel cell back at 0, 0, 0. And we'll drop this ship module widget back at 0, 0, 0, so that we can see them real easy. And when I press play, I can actually look at this and, you know, see what sort of editing we might want to do. We're going to need a ship module edit core as well. So let's create that. Ship module edit core. This is actually the edit widget, isn't it? Because these are the edit handles. God damn it. Handle. Now I've got to open that up and change it in the file. It used to be that Unity would do this for you. And drop it in. Oh good, it updated automatically. That's a new feature. Hurrah! I was hoping it would. Let's create a new script now, which we will call ship module edit widget. And this will be the actual widget that we are editing. What happened to the ship component? Edit. Component. No, that's not component. That's component. There we are. Perfect. Drop that onto the widget itself, like so. Boom. Now you might be wondering what we're doing with this sort of stuff. Well, obviously what we're going to do is we're going to pass the widget commands for specific kinds of editing. So in order to do that, the widget has to know what object it's supposed to be editing. The easiest way to do that is to actually mount the widget on the object. And so that's what we're going to do for now. I'll close others here. So we're going to just put this inside of the fuel cell. And what we'll do is each of these handles will be responsible for communicating to the widget that something has happened. So protected ship edit widget widget underscore widget, and then we'll do a proper public widget get if widget equals null, then widget equals get component in parent widget. Oh, that didn't work. There we go, and then we'll return widget. So in this way, we can always ask the ship component edit handlers to grab a widget when we need to find it. That should be a fairly easy thing to work with, but we don't have any commands for actually doing any editing. So we're gonna have to do that now. So we're gonna have a couple different varieties of editor. These rings are obviously rotational, so we're gonna want to have public not Unity, enum edit handle type unknown rotational scale or offset and scale, translate and scale. Public edit handle type equals rotate. And what we're going to want to do is allow this to be called with a simple offset command. So I'm trying to figure out the best way to do this for rotational control. Obviously, I can just make it so that when you click and move your mouse, it will track how far you've moved and use that as some kind of delta. But well, I guess that's a good way to do it for starters, at least. public void mouse move, and then vector 3 delta. I don't know. We'll have to think about that. I'm trying to think of the best way to do this, and nothing is coming to mind that's any better than just tracking the movement of the mouse. Well, I really want the idea to be you drag it and it clicks properly as you move across the mouse. To do that, what I'll need is the location of each mouse event. So what we're going to want to do is do a mouse move and then a vector 3 contact point. With the idea being that if it's rotation, we can just go ahead and rotate contact point. Public void rotate. That's not how you spell void. Vector 3 contact point. So what we can do is we can figure out the angle between this current contact point and the last contact point. So protected vector 3 earlier contact point, original contact point. Public void contact vector 3 contact point. Original contact point equals contact point. So then what we can do is down here we can compare the angle from the original contact point to the new contact point. To do that, we have to determine what is our up and what is our right. So in order to think of that, we're going to want to convert our contact points into dots relative to the vector up and the vector right on the transform. So vector 3 or float y equals vector 3 dot dot, and then we're going to go ahead and say transform dot up comma contact original contact point. Float x0, same thing. But with right. And we'll do the same thing for x and y1, but with, of course, the new contact point instead of the original. So in order to get the exact angle values, we'll want to get the mathf.atan2, y0, x0, and then same thing for a1. So that'll get the delta between where we originally were and where we are now. The thing is, what we want to do is we want to wait until it is being triggered, because until it actually clicks, we don't care. But once it clicks, we care. So float delta or margin equals mathf.absolute value a1 minus a0. And then if margin is less than our universe dot, what is it, click? It might not even be in the universe. It might even be in the ship editor. Let me look it up. In order to do it, we have to know what angle is currently set as our angle. See how we've got this angle setting here, rotation snap? We're going to want this rotation snap to actually be what we check. And so if we look at the input field, when it changes, it talks to the exterior construction controller. So that's where it is. The exterior construction controller is called the ship construction control. So it is on this. Oh, it's just not static. It's global. Well, you know what? Those should really be static. We should probably put them on the universe as well. Well, we can deal with this anytime we want, really. All right, let's see what that breaks. This dot grid size equals val. It's not of this. This at angle snap equals val. That's not of this. Cannot implicitly convert float to string. Stop highlighting random shit. Jeez. Cannot convert. Where are you getting a string? Angle snap is a float. Val is a. Oh. They're both named angle snap is the problem. That will do. All right, so that should work in theory. Not at all sure in practice. We'll find out shortly. But the point here is that we can grab that value over here in our handle. So it's an exterior, it's a ship exterior, ship construction control dot angle snap. This will allow us to quickly get what angle is our limit. If we are under our limit, then who cares? Under the limit, who cares? Return. Yeah, just return. If we're over the limit, then we want to rotate ourselves to the new angle. And, oh, okay, that's that. Yeah, this will work. We'll want to rotate ourselves to the new angle and apply that new angle, and also that is the change. And we're also going to want to save this contact point as the new initial contact point. So original contact point equals contact point, and we'll want to rotate it one way or the other. So we'll want to get our ship component edit widget ready. Public void rotate object, and then we'll do float. Oh, you know what? We don't have to rotate ourselves because we're rotating the object and we're attached to the object. Yeah, this will do. This will work. Except for it's not a float angle. I think it would be best if, rather than doing any kind of rotation here, we just allow widgets to, handles, to grab the transform in question. So public transform component. Protected transform underscore component. Get if component equals null, then component equals get component in parent component, ship component, right? It's just ship component dot transform. Return component. If component still equals null, well, it'll actually crap out. So it'll crap out, so we'll be able to see it using the defaults. So that should work. If we wanted to get the components transform, we just ask the widget for it. So up here, we're going to go ahead and did I call that? Okay, so we're going to do the same thing to our ship component edit handle. Public transform component get return widget dot component. There we go. So if we come down here, we can say what we're going to do with our component, and we're obviously going to be rotating it. But the question is, how are we going to be rotating it? The answer is we're going to be rotating it around our up axis. I think it's our up axis. It might be our Z axis. Either way, just a little bit of experimentation will quickly show whether or not that is the case. So component.rotate, and we can specify an angle, which would be our ship construction control.angle snap. And then we're also going to want to check whether or not it's positive or negative. So we're going to have to actually do this. Float delta equals ship construction control.angle snap. If A1 is greater, is less than A0, delta times equals -1. Delta relative to local, yeah. That's not local. In fact, that's about as far from local as it could be here. Space.local, self, there it is. But there is more to this question because we're giving it a float, and what we really want to do is give it an axis. And so, okay, the axis comes first. No problem. Vector3.up. Oh, but this is space.self rather than, okay, so that would actually be their self, not us. So we are going to have to use our own .up. Now, when we look at it, our components are set up so that we can determine what up is. And up is the y-axis. So up is correct. Good. So that way, we should be able to rotate. We might be rotating in the wrong direction right now. We'll find out shortly. But it should rotate. We're going to go ahead and take a look at what the heck it's complaining about. Contact point is a type. Because you capitalized it randomly. Congrats. Okay, so now all of that is set up, but we have an issue where we are not able to click on these because our ship construction controller just doesn't understand the concept of those things, these newfangled thingies. So what we're going to do is we're going to come down here into our unloaded cursor menu. This or function. This is the function that handles all of the all of the mousy stuff when you're not actively carrying an object. What we want to have happen is we want it to detect ship component edit widgets, or handles rather, as well as just ship components. So here you can see that we are looking for a highlighted component, and we're trying to find a system here where we can figure out what we're doing. But this is when we're clicking and we have a highlighted component. What we'd like to do is we would like to have an alternative. See here where we've got this highlighted component system going on. There are two categories of things we might highlight. There's the highlighted component, but there's also going to be a highlighted widget. We have a couple of options here. One option is we can descend from the same class, but since their functionality is so radically different, there's no reason for them to share. We're never going to want to pick up an editing widget. Those will react in a completely different way. So rather than over-engineering this, we're just going to have two different possible highlights. So if we look at this, we've got active component and a highlighted component. Here it is. So we're going to want to put in some notes here for future selves. This is specifically a component we want to click on and stuff. Whereas up here we'll have our public ship component edit handle, highlighted handle, and then we have the same thing that we have down below. Having this getter and setter allows us to do some automatic stuff when we are trying to set these things up. So you can see with the highlighted component, it actually establishes that glowing outline. We're not going to be doing a glowing outline yet, but we want to set up a future where that is possible. And here we're going to say this highlighted handle is the one we're going to use to edit our object. Whoa. I've been talking too fast, I think. Got dizzy for a second. All right. Phone's making noise over there. When we have our ship construction control, we currently only try to detect the highlighted component, see? So what we're going to do is here, when our highlighted component equals null, we're not going to cause an error anymore. There's no point. I'll just delete it entirely. There's no reason to worry about that. So that will automatically get it set to null if it's on something that's not a highlighted component, and that's kind of the point. Here we're going to have a highlighted handle equals hit.transform.getComponent highlighted handle. No, that's a weird-ass underscore. Handle, ship, there it is. So that should allow us to get the highlight and the handle. And of course, if we're not clicking, if we're not on anything, we shouldn't show the handle or the ship component, except we don't want to unselect the highlighted handle if we are mousing off of it, because we'll go ahead and unselect it. I'll have to figure this out later. It requires a little bit of dexterity. Once you've clicked on it, I want to kind of lock it in. Yeah, okay, we'll leave it like this. We will leave it so that it is locked in. But these are actually the same, aren't they? Back and forth, trying to decide upon the best approach. So what we've got here is a situation where our highlighted handle is going to get set to null if we ever accidentally mouse off our highlighted handle. So the highlighted handle is only going to change if our mouse is not mouse down. So actually all of this can just be if we are not mousing down. If input.getMouseButton 0, so if we're not actively holding the button down, do this nonsense. Otherwise, we'll stick with whatever we've already got highlighted. That's fine, thank you. So here down below, what we've got is the situation where if we've clicked and there is a highlighted component, then we pick up that highlighted component. We're going to want to expand this. So if clicked, protected void unloaded click. So this unloaded click, this will be what actually determines what happens when we click the mouse. And obviously, if we have a highlighted component, pick up a component, then that's what we're going to do. And we're going to want to have that be something that happens whenever you are doing something useful with a component. But if we're on a handle, what we want to do is grab the handle. So we're on the highlighted handle, and what we're going to want to do is actively try to find our vector on the handle. Now, the reason we can't use what we already have up here is because this raycast is trying to actually... Hey, begin attack run. And Soup of Can stopped by to tell me that the chat room feels awfully quiet. That's because there's nobody here. It's just you and Begin Attack Run. If you guys want to spice up the chat room, feel free. There is a new version of this out. I don't know whether or not you guys actually know where to get it. I think it's shown on the non-dashboard version of my page. Let me just quickly double check while I'm here. If I go over here, you can get the, you can just go follow that download it link. I think that you can actually see that, and you'll be able to get the new version. It's still just a prototype, so don't expect too much out of it, but it's certainly better than the not playing it. And Evil Luigi is always here. Didn't mean to discount him, but like all Luigis, he is kind of fading into the background. I always play as Luigi. Not the evil one, though. All right, so we've got this unloaded click, and as I was saying, when you are mousing down... Oh, wait, hold on. If clicked... Clicked might actually have a special term meaning here. Let me just take a look and see whether or not clicked has a special meaning. Okay, yeah, so clicked only happens on the initial mouse down. So if we do that, then this won't actually make any sense. So we're not going to be doing it quite like this. Basically, if you're clicking, we only care if you are clicking on a component. But if your mouse is down, we might care a lot about other things. Because when we're dragging on one of these objects, it's much more important for us to remember how we've moved. Oh, but you know what? We do need to have... Sorry, back and forth and back and forth. I'm not paying too much attention to Evil Luigi, so I'm afraid you're going to have to kind of just flow with it here. Soup of Can says, code style suggestion, but couldn't you do if variable instead of if variable does not equal null for null checking? Looks neater. You can in some languages. I don't believe you can in C#. I guess you can. I did not know that. That is a pretty good tip. So I actually didn't realize that you could do that in C#, which is why I haven't been doing that. But one of the other things that's worth considering, Unity has this issue where it considers things that are quote-unquote destroyed as null, even though they're technically not. But I guess that's not a concern here. You are right, Soup of Can. Thanks for the help. So, I'm trying to get this straight in my head. Basically what happens is we click, and that's when we set the initial contact point on our handle. And after that, mouse drag is what we need to worry about. So if highlighted handle, then we want to set our initial hit. So I think it's called, it's not called a click, it's called a... contact. And then we can pass it our quote-unquote contact point. What's our contact point? We don't really know. Let's go ahead and create a function specifically for determining the contact point with the highlighted handle. So if we go up here, we can create a new... we probably don't want to put it there, though. This is getting a little bit messy. We're going to want to put this in code regions at some point in the near future. Protected, vector3, handle contact. So down here, we can just say contact, handle contact. And up here, we can create a new function for trying to figure out what exact place on the plane of the handle we have currently got our mouse. Now, the difference between this and an ordinary raycast is that this will find the point on the plane even if there's no contact. That's important. So what we're going to want to do is put in some checks just to make double sure. If current handle, what's it called? Highlighted handle equal, if not highlighted handle. Can we negate like that in C#? Okay, yeah, that's fine. If not highlighted handle, debug.log error, tried ship constructor, tried finding handle position on a null handle. Return vector 3.0. Begin attack run says, doesn't that always work? There are actually plenty of languages where it doesn't work, and for some reason, even though I've been coding in C# since the very beginning of C#, I thought C# was one of those. So down here, if we do have a handle, we're going to want to find a new point. So to find that point, we can take a look at our unloaded cursor. You can see that we have this ray here. We create this ray, and then we create this raycast hit. We're not going to need the raycast hit, but we are going to need this ray. Now, right now we're using camera.main, which is a little bit stupid, but that's okay. We'll leave it like that. And what we're going to want to do is find the intersect on the plane. Now, I don't remember the best way to do this. There is a find impact on plane. Is it part of the plane? P dot raycast. There it is. So we need to create a plane, new plane, and obviously our plane is going to consist of the vector up and vector right on the handles. So if we take a look, you can see we've got an in normal and an in point. ABC. I'm going to go ahead and use ABC because I know how to do this perfectly, and I'm not actually sure what an in normal and an in point do. I'm not sure which direction that works. Is that like the... So if I were to do this in normal and in point, would the point be the center and the normal be up? Let me go ahead. Unless any of you happen to know, I'm going to look it up. Unity plane. All right, so constructors. So resulting plane has normal in normal and goes through a point in point. All right, so in other words, it is exactly like I thought. That's actually a little bit easier. Good, good, good. I like it when it's easy. So what we're going to do is we're going to pass it the handle, highlighted handle dot transform dot up, and then we're going to use the endpoint of highlighted handle dot transform dot position. And then we're going to say p.raycast ray, and then we're supposed to figure out where it is ray casting. Out float enter. That's not what I want at all. Begin attack run says, have you ever been to GDC? I went twice. It's not my thing. I am not very good with crowds. But there were a lot of good talks this year, and I'm looking forward to at least some of those coming up in the archives. So, raycast isn't what I thought it would be. Out float enter. Why would it be a? Oh, it's the distance down the ray. I see. I see. Can I? I guess I do need to use that. Okay, so it's ray, and then out range. Float range. So when we get that, we need to find the point. So vector3 hit equals ray.origin plus ray.direction times range. And then we pass that hit over to our friend the handle. Highlighted handle. No, wait, we just return it. Return hit. Down here, we pass it to our friend the handle. So what we've just done is we've made it so that when we click on one of these, it knows where we've clicked. Let's go ahead and add in a nice little debug line and test it. Because we've been going a long time now, almost an hour, without doing much testing. So debug.log clicked on component at, and then contact point. Sorry, clicked on handle. Plus name, plus at, contact point. All right, let's give it a shot. See what it says for itself. Begin attack run says, gotcha, so far I've just watched a number of the talks online. I hear the primary value is for the networking, which I suppose is true since a lot of the educational theory stuff is freely available for watching later. Yeah, I agree. There are a lot of networking opportunities at GDC if you know how to network and like networking. As you will be unsurprised to hear, I'm not really great at it. Oh, that was weird. Oh, because it's... Okay. So what I've just found out is that we have a order of operations problem. So if we look down into our click, here it is, our ray, rather, unloaded cursor ray. What we have is this highlighted component. When we search for the highlighted component, what we actually do is we search for in parent, get component in parent. And that means that we do end up with a highlighted component, even if it's part of a highlighted handle, because our highlighted handle is inside the component. It's easy enough to fix. We say if not highlighted handle, then do this. Otherwise, set it to null. And that should fix the situation. Let's take a look. Clear. Boom. Boom. Clicked on handle 1 at -1504.8. Yeah, it works. So now let's get the dragging working. So in order to do the dragging, we need to have a mouse down query. So else if input.mouse down, not mouse down, just mouse button is down, not the moment of click, but continuously until it is no longer clicked. Unloaded drag. Protected, that didn't work. Protected void unloaded drag. If highlighted handle, so if there's no highlighted handle, return. If there is a highlighted handle, then guess what? We need to just tell it to update. So highlighted handle dot drag, no dot mouse move, and then the contact point, handle contact. Perfect. And that should do the trick. Let's take a look. Let's go ahead and put in some debug lines. Debug.log. Dragging handle, and then the margin. So let's try it out. Dragging handle. Huh. We're clearly doing some math wrong. Let's go ahead and try and do some math right. In general, given the choice, do math right rather than doing math wrong. It helps. So you can see down there in the corner, we've got 3.14159 as our angle in both cases. That is a strong indication that there's something stupid happening. Because as you may know, that is pi. So we really shouldn't have that be anything, and it really shouldn't be like that unless there's something. Oh! I'm just an idiot. So the contact points are not in local space. They're in global space. So we have to subtract our local space. But hold on, we're currently at 0, 0, 0, so that actually shouldn't be an issue. So this isn't going to change anything. It would be a bug. I fixed a bug, but it's not the bug that we are having. So as you can see, I'm not getting any good responses here. It must be a problem with the X and Y 0 elements. All right, let's see here. Now, in theory, these should be based on the up. Oh, of course, it's freaking up, isn't it? I'm an idiot. Brilliant. Brilliant. Yes, it's not the bug we want, but it's the one we deserve. All right, that's much better. So here you can see that we have a steady change in our angle, but our angle is being specified in radians. So if we click here, then we can see that we're getting a steady change in radians, but we need it in degrees. Or, alternately, we need the other part in radians, because we are looking in our angle snap value, and our angle snap value is not in radians. So we're going to need to make that 2 radians. Oh, it's a float math. Let's try it. mathf.2 radians. There it is. Now I actually don't remember. Why are you red? Oh, it's just a value. I actually don't remember whether or not you specify this part in degrees or radians. I suppose we'll find out. The rotate function looks like it could be implemented without as many dots and atans, but I'm not a mathematician. Yeah, you're probably right. Well, it's certainly going by 45 degrees. However, it is clearly not going around the proper axis. So if we try and drag this way, you can see how it's spinning around the blue axis rather than the green axis. So that means that it's just attached to the wrong element in terms of its upness. If we go over to our ship construction control, oh, here it is, ship edit handle, component.rotate, transform.up, delta, and space.world. Let's try transform.forward. I have a feeling that there's something screwy going on here with the fact that this is mounted. Yeah, that's the problem. So the problem is that our object is not mounted in on an unrotated object. So we're currently mounted on a rotated object. If we go down to the ship module widget, you can see that it's rotated by 90 degrees. There we are. So now, if I try and rotate this green, boop, come on. Boop, that didn't work at all. Did I get the blue somehow? Because it's, no, it's definitely not right. This is odd. And Supifcan, you're almost certainly right, but I'm not too worried about that kind of optimization. It's highly unlikely that this is going to end up slowing things down. Alright, you know what? Let's change this so that... Oh, it's set to 30 degrees rotation snap, but it is clearly rotating at 45 degrees. Okay, so we've got some wobble, and it's definitely going the wrong direction, and there's something wrong. There's a bunch of stuff being stupid here. So, if we take a look, first off, this is just going to be the opposite. But second off, we have this issue where the original contact point becomes the current contact point, but that is somehow oscillating rapidly. That shouldn't happen because the contact points should be always be represented here based on the current transform. So even if the contact point changes, it shouldn't vibrate. Let's try one more time. Oh wow, this is... Is it because the ATAN2 is fucked up? If I do a plane, can I get the angle of a point on the plane? No, I can't. Alright, so what is causing this issue where it vibrates rapidly? If we do a debug.log margin, we will at least get some margin. We'll at least get some note as to what's going on, but there's something screwy happening. You know what? Stop. I don't want to see that. I would rather see it as an angle. There are a lot of things that could be wrong here. For example, it could be that the place is wrong, like we're not actually clicking where we think we're clicking. So here you can see that it says that we're just a couple of degrees off. And at 90 degrees, it suddenly jumps up, and you can see that we're just increasing. This says to me that there's something wrong with the atan function, or with the way we're calculating x and y. Generally speaking, I try to do this off camera. I didn't think it was going to be tough, though. I was just like, this should be basic. No, it's not basic because you don't have a brain. So you can see here that what we've got is, oh, they're not normalized. All right. And we still got the same problems, though, so the normalization wasn't the issue. So you can see that as I'm dragging down here, you know what? I'm going to hide two of these widgets. Boom. So as I'm dragging here, when I hit this 90-degree angle, it's still saying that there's 15 degrees. But as soon as I break past it, it shoots straight up and becomes this weird number that doesn't work right anymore. So this is, in theory, that's in theory directly above the object. And you can see that it's not giving me the numbers I need. It's coming up with random nonsense. If I look at the values on the right, you can see that the x value, which is increasing at basically 0, a rate of 0, which is the problem. Did I spell it wrong? I bet I spelled it wrong. No, it's just a contact point. It might not... Is the ray not in world space? Is that the problem? So if I click here, it should be at 1. Yep. If I click here, it should be at -1, 0. It's at 1. Okay, so that's not right. Because these are the same, and that doesn't make any sense. Okay, so there's something obviously wrong here. We're getting 0 values on the x vector, and 1s on the y vector throughout. So the x vector is the right, and the y vector is the forward. And for some reason, this is not working. I don't think there's a missing semicolon, but there are a lot of problems with whether we're in local space or real space and stuff like that. It might very well be that one of these is supposed to be an up rather than a forward or a right, but that would be weird. They're both wrong. That's the thing. If one of them was right and the other one was wrong, I'd be a lot happier. But they're both wrong. Well, when we do this clicking here, let's go ahead and calculate out the value and get ourselves a value that we can just list here when we're on click, because that'll be a little bit faster. So float clicked, and then we'll just say clicked on handle name at, and then we will go ahead and give the x0 plus y0, and that'll allow us to quickly figure out what we're currently looking at. Mr. Idle says he's confident that I will manage it. The funny thing is, I've done this 100 times, maybe more. This is some basic shit. There's something in here that's not working right, and it's probably a conceptual mismatch between what I think the program is doing and what it's actually doing. So I'm trying to track that down as we speak. Here you can see down in the corner it says clicked at handle at -0, 1. Then I go over here, and it should be -1, 0, but it's still -0, 1. And then down here, -0, 1. And then over here, -0, 1. Over here, -0, 1. It's always -0, 1. And that's obviously there's something screwy going on, because that's like, duh, that's not right. So the contact point is in world space. So we'll just put in the contact point.normalized and see what sort of, maybe it's the raycast is going wrong. Like the plane that I set up isn't raycasting properly. So if we take a look, it says that we are at 0 and 1. And then if I click here, it says that we're at 0 and 1, 0 and 1, 0 and 1. Okay, so the problem is the raycast. The raycast is not working. Everything else is working. Okay. I can work with this. I can figure out why the raycast isn't working. Now I'm using a method called the plane. This plane here has a raycast function that I obviously did not use correctly. I didn't figure it out like I thought I did. Begin attack run says, could you make a raycast visual? Yeah, I can if it doesn't work out this time. But basically what I'm trying to do is raycast to a plane. And I was using the plane as the raycast thing. But for some reason, this isn't returning the values I thought it was. Debug.log. I can just raycast shows range and then range. Let's go ahead and try this out. Raycast shows range 3.8. -755. Okay, so the raycast is not doing what I thought it was doing. So this is not the function I need. p.raycast is not giving me the values that I want. Let's look it up. Unity raycast plane. Plane.raycast, explanation of plane.raycast. What is plane.raycast? All right. This function sets enter to the distance along the ray where it intersects the plane. If the ray is parallel to the plane, the function returns false. If the ray is pointing in the opposite direction of the plane, function returns false and sets enter to the distance along the ray negative value. So that's actually correct, which means that I must be specifying the values incorrectly. Thank you, Eva Luigi. I was worried that you had accidentally gotten that one word wrong quite a while ago. So I don't know whether or not it's the raycast or the ray that's wrong. Let's go ahead and find out. Protected void on draw gizmos or on gizmos draw. I can't remember which it is. Gizmos.draw ray. We're not going to actually be able to see that very well. That's not going to work. We can draw the plane though. So if highlighted handle does not, just highlighted handle, that's fine. Raycast, no, gizmos. Draw plane. I bet there's no draw plane, is there? There's not. Draw a cube, draw a frustrum, draw a sphere, draw a ray, draw a mesh, draw a line. Guess we can draw a line. Let's find out. I can't even tell whether it's drawing or not. Okay, I think I might be able to just I don't. There's no drawing a big square. I could draw like a zero space cube, but I don't know how to tell the plane. So when I specify the plane, I'm using this method where I do the normal and the point. Which direction the normal points, I don't care. But it's clear that we are not using the correct value here. And I bet that's it. I bet that's all it is. Raycast range shows 50, 55, 50. Yeah, okay. So it was just a case of mistaken identity in terms of the offset. So let's go ahead and A, turn these handles back on, and B, turn some of this debugging off. And I'm 99% sure that this is now doing what I want it to do. And after all of that, it was just me misunderstanding Y and Z. Again, always. If I had a nemesis, it would be that. Okay, so it's still wrong. So it's rotating 45 degrees, even though I've told it specifically not to. I agree, begin attack run. Mario is definitely the villain. Okay, so what we can see here is these are very small values, so maybe I didn't fix it after all. God damn it. I thought I fixed it. I deleted a lot of shit just so that I could show off that I'd fixed it, and then behold, it's not fixed. I bet I know what the problem is, though. So if I click here, it's 0, 1. Oh, hold on. 0, 0. Yep, I know what the problem is. Ah. Let's go ahead and see whether this properly rotates. Boom. Shaboomp. 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 Properly rotates, except for some reason it's convinced that I have it set to 45 degrees. Which I don't think is true. It might be. Maybe I did set the default to 45. I did. I'm just an idiot. So it's currently inverted. So let's go ahead and fix all this up. Hurrah! We are now well on our way towards having a functioning widget. I know that's why everyone comes by, right? You want to see me make a widget. Let's take a look at our exterior construction controller here. You know what? I bet I know what the issue is. Yeah, see, here it is. Just change this to 30. Because it used to be not static, it used to be local. And when it was local, obviously it would keep whatever values I put in the inspector. Now that it's static, it doesn't. And that should be okay. Doop, doop. See? Doop, doop. Doop, 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 doop. Doop, 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 doop. Now we're going to want to put some highlighting in because this is not very friendly to the eyes to try and figure out whether or not you've actually got it highlighted. So what we're going to do is we're going to steal the part highlighter and use it for the same purposes. So you can see what we've got here is this highlighted component thing. And we're going to go ahead and just basically copy all of it, except we only need the highlighter. So if we take a look here, this part, we can paste that in here. So if highlighted handle does not equal null, so if there's a highlighted handle, then find the highlighted component mesh filter. So that's not like we're going to use a highlighted handle. And we don't need the children. It can just be right there in the object. We're going to say if that's, so it's a object has no mesh filter to highlight, highlighter.get component mesh filter that shared mesh equals null. That's fine. So we get the shared mesh. We get the highlighter get component mesh.shared mesh. We set it equal to our mesh filter. And then we set up our materials so that they work properly with the correct number of materials. And then we stick it in the same place and at the same rotation and the same scale. That should do. Oh, except for... Yeah, that's fine. That's fine. That's fine. So if we click, okay, it's not working. So let's see whether or not we can get this to actually work. It should, as soon as we mouse over it, it should pop up. See how it says highlighting handle? But it's not working. So let's find our, oh, it's working. See, it's glowing. That's definitely in the right spot and doing the right thing. If we look at our highlighter, there it is. It's right on top of us. I know what the problem is. These handles are actually in the same visual space as the highlighter, whereas it would be better if they were in the ship space. Boom, got it. What do you guys think? Is this a better way to handle it? So one of the things I'm not sure about is if I want it to be 1-to-1. Right now it's like this 1-to-1 interaction where if you rotate it 45 degrees, it rotates 45 degrees. Is it better if I were to just double that so that you would have a more responsive system? Because, I mean, it's not as responsive as you might like. Let's try it. Let's multiply it. So if we just set this up with a static value, public float. Yeah, you know what? I should probably start to make this stuff put this shit on the universe rather than on individual stuff. We'll migrate all these values over into the universe here. Region, global player value, player settings, and region. Public float widget rotation widget multiple equals 2. And then over here in our ship component edit handle, I will apply that to our margin. It didn't recompile yet, did it? No. Now the fun thing about this is I've made it really, really easy to automatically serialize all of these values. Sort of. Because I don't know whether or not my serialization system will serialize static values. It may only serialize... No, it'll serialize static values. Yeah. So begin attack run says, is universe your main game script, like the one that persists for the whole play session? Yeah, that's exactly what it is. So now I've doubled it, and you can see it's a lot snappier. I think double is probably the right amount. So there are still some things that I want to do with this. One is, if you double-click these, I would like them to revert. And so we will go ahead and program that in now. Oh, you know what? If highlighted handle equals value, return. Don't keep spamming that operation. There's no reason to. But if we click twice, and it is the same location within like a small value both times, then I think it is worth making it into a double click. So to handle that, what are we going to do? We are going to set up some kind of double click checker. Or you can make it a right click. Do you think a right click would be better? I think a right click might be better. So if we have a unloaded cursor and we clicked, I believe that click is mouse button 0. So else if right clicked, I don't believe I have a right clicked. So if I look here, clicked is this here. Right click will be the same thing, but for the right mouse button. Now the reason that these are different from just checking the mouse button down is because of this mouse on UI element here. This mouse on UI allows me to block any sort of interactions in 3D space if there's any UI element interfering. And that keeps me from accidentally clicking through a UI element to, say, pick up a ship part when I'm trying to click on OK or something similar. And it's very handy. So that was a nice find. a nice innovation. But what I don't have is that programmed. Unloaded, right click. And here we're going to say, if there's a highlighted handle, then we're going to tell it to revert. We're going to go over to the highlighted handle and put that in. So when we revert the transform, what we're going to want to do is just find our component and set our rotation to nothing. So it would be quaternion.identity. Debug.log reverted rotation for class component.name. Reverted editing values. Reverted rotation and scale. Now the reason I'm doing this is because in theory we might want to set these so that we can change the scale as well as the position and all that stuff. So it could be fun to set this up so that you can do a lot more stuff with it. So now what happens is if we rotate and we right click, it didn't work. Unloaded right click if right clicked. If highlighted handle, revert the transform. Maybe it didn't compile? It's always possible. The right click isn't taking. The question is it not counting as right click or is it not triggering at all? Debug.log. Alright, so it's not detecting the right click. Our right click script that I just implemented must be broken. So if not get mouse button down 1, return false. If mouse on UI, return false. Return true. That should work. Right-clicking might trigger a different event that doesn't get through to this system. If we look at the control update, we can see it here. Input.get button, pop-up, altered control, cam control. Right-click is reserved for the camera. That's the issue. Bye, Eva Luigi. Have fun. I didn't get any sleep either. So the problem is that when you are controlling the camera, it doesn't attempt to update this shit. So we're going to have to put in a special case here. Else camera control is active, but if input dot else if right clicked, but we may have use for that right click anyway. And what we're going to do is we're going to say if, no, that's not right. If handle highlighted, then we'll want to revert it. All right, that should do. So now if we rotate this and then click, it reverts. But that particular reversion looked dumb. So we'll try it again a couple of times here, yeah. So one of the core problems with this is that reverting it actually reverts it to 0, 0, 0 rather than the original rotation. So we got a couple of issues, a couple of possibilities here. One is that we can revert it, we can save whatever rotation it was when we first created the widget, and then revert to that rotation. The other option is that we can revert to this. I think that this is probably safer for a variety of reasons. And you can see that this editor still works in terms of setting all of this up. But when we rotate this, it does not rotate the mirrored version. It only rotates one of the two. And we're going to want to have that work. And one of the things we're going to want to have happen there is the ship construction control actually handles that rotation. It uses a loaded cursor down here, and it checks for a variety of mouse clicks and such. Here it is. And you can see that what it does is it says cursor transform rotate blah, and then it says mirrored rotation mirror cursor rot cf. So what we're going to need to do is also use that mirrored rotation. So one of the issues is that mirrored cursor may not be, yeah, that's fine. So we're just going to copy this. We're going to go over into our edit handle here and have this take place with the mirrored cursor as well. It's not the cursor though, is it? It's the object. The individual objects do not keep track of their mirror counterpart. I have to think about this. Because they don't keep track of their mirrored counterpart, we have to search for their mirrored counterpart every time we want to try and do this. Searching for the mirrored counterpart involves going through all of the objects on the ship and looking for the one that's in the opposite position and has the same name. That's something that should be on the ship. So we're going to pop over to the ship. And it's actually going to be on the ship component. There we are. Here it is. Ship component list. So we've got the ability to find parts here in the list. We're going to want to make it so that we can do a much more aggressive system for it. So down here we'll say region editing and region public void, I know public component, right? Yeah, public ship component find, and then we're gonna go ahead and say it's string name vector3 position. And what we're going to want to do, make this a local position. What we're going to want to do is just look through all of our components for it. So right now, we're going to take a look at our list of components, for each components, ship component. I cannot type anymore. My brain is gone. In components, if name does not equal null and name does not equal sc.name, continue. So basically, if you enter in a null value as the name, it'll look for any component at that location. Otherwise, it will look for something that perfectly matches the name. So then we're going to go ahead and check the local position. Here's where it gets a little bit obnoxious because the local position is a float value, and it may not be precisely that. Oh, wow, the sky is orange. We were supposed to get a hell of a thunderstorm, but it passed south of us. But we still got the weird orange sky. Neat. All right. Right. So we have to actually check the delta between them rather than checking if they're equal. So if local position minus sc.transform.local position dot magnitude is less than 0.001f, then it's the right one. Return sc. Return null. So Subafcan says, seems a bit unsafe searching for mirrored parts like that. Can't the parts keep track of their mirrored counterpart instead? I mean, they can. Is that any better? No. Well, I still want to have this function, even if it's not searching for mirrors. Let's go ahead and take a look on over at our ship component. So our ship component does not keep track of its mirrored part, but there's no reason it can't. So we'll go ahead and add that in. Public ship component mirrored version, or mirror. And we'll just hide that in the editor. The mirrored version of the part, if any. And then what we're going to have to do is over in the ship construction system, when we place the parts, we'll have to set each of them up to have their own mirror. And that is loaded cursor click. There it is, if clicked. So we're going to want to say, for each transform t in cursor, t.set parent ships. So cursor is a transform. There's only going to be one ship component in it, though. So we're going to go ahead and say ship component A equals cursor.get component in children, get component in children, ship component. And B. If let's just put these both in the mirrored cursor. No, A has to be outside, and then B can be in the mirrored cursor. So in this case, what we're going to do is going to say A.mirror equals B, and B.mirror equals A. And up here, we're just going to say A.mirror equals null. So let's go ahead and put some debug in. If it's not, well, it'll cough up some damage if it's not true. So that should work. That should be everything we need to set up the mirrors properly. Then over here in our ship component edit handle, when we're trying to set up the other rotation, we want to get the ship construction controller's mirrored edit. And I believe that's static, yeah. So we can just grab this and ship construction control dot mirrored rotation. Got the transform.target, which is our component.get component ship component dot mirror dot transform. And then we're going to want to give it the angle and the axis. Yeah, that's fine. I'm not sure whether this is going to work. I have a sneaking suspicion the axis might have to be in local space. Let's find out. So in order to do this properly, what we're going to have to do is actually create a new set of objects, which we can do just by picking this up and dropping it. Boom, it's now in the ship. But you can see we've got some damage, and I think that's because it didn't understand what's going on. Did I have an error, a bug? So when I get the cursor component, it barfs. I think that might be a barf that happened after. I think I've got a different barf when I first did it. So, was there an error? I don't know. I think I know what these errors are now. These other ones, which I think I know how to fix them. So here it is. B.mirror equals A and A.mirror equals B. Does A and B have a different meaning? I don't think so. Oh, no, that wouldn't change. Johnny Boy says, when something is static, what does that mean? Supifcan says, I believe static makes variables persist through the duration of the program rather than being destroyed at the end of scope. That's not the case. So this is object-oriented programming stuff. There are two kinds of variables that you can put onto a class. One is the kind of variable that you're familiar with. So for example, if we go over here into the universe, we got a couple of these variables down here. Public float hours per day equals 24. That means that if you look at the universe, we've got a specific universe. And this specific universe has the number of hours per day 24. If we were to change that, then this universe would have a different number of hours per day, but a different universe would still have whatever values it has. On the other hand, there are some static values, and these are attached to the class rather than the instance. So no matter how many universes we have, you're only going to have one value for this. So for all universes, rotation widget multiple is 2. But for any given universe, they might have different number of hours per day. So if it is a static variable, it's one variable for every instance of that class. In fact, it doesn't even require instances. Anyone talking about that class in any way can see that one specific variable in the current value. But if it's not static, then every single universe, every single instance will have its own version of that value. I don't know if I explained that very well, but I hope that helped. So where was I? I was doing mirroring, and I was like, what's going on? Well, I think that what's going on is that this is not in the right spot and doing the right thing at all. So we're going to go ahead and try and create an object. Just create an object like this fuel cell. And just stick it down. Okay, so there is a new bug. I have introduced a bug with this AB stuff. And I don't know what it is, because these should work. Well, I guess what we'll do is just ask it what the hell's going on with the A and the B stuff. Debug.log A is plus A. B is plus B. A is fuel cell ship component. B is null. Oh, because I am an idiot. Hurrah! Isn't that just the most fantastic solution? Anytime something goes wrong and you're programming, it's usually because you're an idiot. All programmers are idiots. There's no way around it. And by the way, Johnny Boy, within any given... That sounds kind of diminutive when I say it like that. By the way, when you have a variable, you can set it up as a public, private, or protected variable, and the default is protected. So public variables can be seen from anyone. So if I have a public universe variable, then that can be seen by anyone who's looking at the universe. Protected ones can be seen by the universe and any of its descendants. And then private ones can only be seen by that specific kind of universe. If you don't know much about inheritance, that might not make any sense. Perfect. Let's try it out. Ah, look at this. It's so beautiful. So beautiful. Soupofcan says, darn object-oriented programming weirdness. C is not much better. I would not think that I would want to try and program any substantial game in C. I know that a lot of games are programmed in C, but most of those have giant teams, some of which are dedicated C programmers, and others of which are definitely not. If you're doing engine programming, feel free to program in C. If you're doing game programming, that's kind of rough. So look, it works, everybody. We can now do this. We can have our widget and eat it too. Woohoo! And this widget should allow us to edit the exact position and orientation of any object we care to create. Now the problem is that right now we don't have any sort of setup for creating this particular widget editor. So what we need to do is create some kind of widget editor creator thing so that we get our widgets when we want them. And look, I just caused a nasty error where I rotated the objects in a funny way, and when I reverted, it only reverts one of them. So let's revert both. So if we want to revert both, that's easy enough. We will go ahead and revert both. Here we are. Oh, this assumes that there's a mirror. So ship component mirror equals, I might as well make this get return component dot mirror component dot get component ship component mirror. To tell the truth, we should probably go through a couple more layers of checks rather than just barfing that out there, but I don't feel like it. So what we're going to do is find, this shouldn't be called mirror, this should be called component mirror. Because it's not the mirror of this object, it's the mirror of the component. And we should stick it up near the component. There we are. Doop. So down here, we should say if mirror, our component, ship component, mirror, m equals mirror, equals component mirror. There we are. One of those combinations of keys will eventually put out the right word that I need. If m, so if there is a mirror to be had, then mirror. Same thing down here. m.transform.rotation equals quaternion.identity, and m.transform.local scale equals vector3.1. Begin Attack Run says, hey Craig, have you ever run into the problem of characters in any Unity game crashing through terrain meshes, like due to high move speed forces? It happened to me and I'm not sure where to start. Sure, I'll teach you how to fix that right now. So pay attention. When you create an object that has a physics, a collision mesh of any kind, you will be able to set a number of parameters. For example, here is my mesh for our new ring. And here you can see the mesh collider over here on the right. Any sort of collider is like this. It doesn't have to be a mesh collider. Oh, I guess you do need a physics object. Sorry, let me go ahead and create a physics object for you, because I'm presuming you're using the physics objects, right? So I've just created this box. And this is your character, okay? So your character is this box. And you've got a box collider or whatever, a mod, capsule collider. And you've got a physics, what is it called? A hard body? Rigid body. And you've got a rigid body, right? So this is how your character looks. And the problem is your character is moving fast enough. Maybe it's bullets. Bullets are also like this. That it's flying through various kinds of objects. Well, that's because of the optimization that Unity does to try and keep these things cheap. But down here, where it says interpolate, you can change it to interpolate. This will increase the amount of computation that it takes, but Unity won't skip anymore. So this means that it will check and make sure it won't fall through any sort of values. It won't fall through any sort of physics objects or colliders. Interpolate means that instead of just looking at the current position, it will actually look at the current position and where it was last time it calculated, and it'll make sure it didn't fall through anything. If you also want to increase it any more, you can do this with the... sorry, I think I just explained that wrong because I was an idiot. That's what continuous does. Interpolate is about how physics movement works. I'm sorry. Interpolate is about interpolating physics. It helps with gravity calculations and stuff like that. Collision detection is what you want to set to continuous. Because what that does is it will take the current value and the last value, and it will make sure that you don't fall through anything when those values have changed. So it'll look between the spaces, and it'll make sure you don't fall through. However, it's substantially more expensive, so be careful. And I'm sorry that I initially gave you the wrong information. It's not interpolate. Interpolate is something else. It's collision detection, obviously. Hope that was clear, even with my stupid. God, I hate it when I explain something wrong and then have to go back and say, I was wrong live on camera, let me start over. Because when I'm doing videos, I'm like, oh, let's do another take where I don't sound quite so stupid. But when you're doing it live, you're going to sound stupid. Right, where was I? We have to create these editor objects. So how are we going to do that? Well, first off, we have to store the editor object as its own little thing in our prefabs list. So we'll go down here into the prefabs, into the UI prefabs, and drop in the ship module widget. Boom. Now what we're going to want to do is set it up so that our machine editor here, our ship component editor, will create one of those whenever we want it to. So for that, we have to know where it is, and we also have to know when we want to create it. Well, let's set up where it is first. If we look down here, there's a lot of variables, and I think we'll want to go ahead and just put it right at the end. Public ship component edit widget, ship component edit widget prefab. Perfect. Now if we look over here at our exterior control editor and we scroll down to the bottom, whoop, you will see a ship component edit widget prefab, and we'll just drop that in. Boom. So with that in mind, now we have to know when we want to create it. And the answer is we will create it whenever you right-click on an object. So when we go down into our system, there are a number of places where that might happen, but all of them get routed through the main update loop. So control update, here it is. So the cam control button is the button in question. So if we didn't click the cam control button, then we go through all of this stuff. If we did click the cam control button, jumping plane to highlight, ground plane dot position. So this is where we want to do it. So not only do we want to jump the plane to highlight, we want to jump everything to highlight. Jump editor to highlight. And what we're going to want to do is create a new editor specifically for our highlighted object. So for that, we're going to go ahead, and I think it would be cheaper to reuse, don't you? So we're going to go up here, and we're going to have a protected variable. Mr. Idle says, "You are quite cool in explaining things. It's the main reason why I keep returning to your stream. I already learned a lot." That's great to hear, because, you know, sometimes you make really, really dumb mistakes. And I guess that's the easiest way for people to learn from you. They see someone who's done a fairly decent job making lots of dumb mistakes. So there's our instance. And we're going to want to have that instance just get saved. There it is. If instance, so if there's no instance, then we create an object. Ship component widget prefab. And then what we want to do is, if there is a widget, we need to tell it that it's no longer controlling the same object. So ship component widget instance dot reset. Over here in ship component widget, public void reset. Component equals null. Otherwise, we will continue to try and affect the other component. Now over here in the ship edit handler, we never look for our component. We always reference the component from our boss. See? So there's no risk of this needing to be reset. So that should work okay. It's only this that needs to be reset. Now that it's been reset, what we can do is move it into our new object. So ship component edit widget instance dot transform dot set parent the new object. So highlighted component dot transform. Is it already a transform? I think highlighted component might be a transform. No, dot transform. And we want to reset the world position, which should set it up properly. Let's try it, shall we? So if we were to load up a new ship like the monkey bars, barf, a lot slower in debug. You can see our leftover component system. We're going to want to try and maybe deal with that later. But when we right click on something, you can see that we create the new one, because this one is like spawned long ago. And then it works. You can see us editing it. Now these objects here don't understand the mirrors. Oh, damn. So when we're loading these objects up, they don't get the mirroring right. So we're probably going to have to do the find after all. That's fine. We can just replace that now. So our ship components are not going to keep track of their mirrors for now. It's just a little bit too annoying when we're loading in ships. So we're going to leave that out. And instead we're going to just search for them. So over here in their ship component list, we're going to have a find mirror. Mr. Idle says that humans make mistakes, and Soupcan says so too. Public ship component find mirror transform object or base unmirrored object. Parent is good. So then we say return find, and that'll actually, we need to make it a vector3 new pause equals parent dot local position new pause dot x times equals -1. Return find parent dot name comma new pause. There we are. So that should allow us to quickly find mirrors if we need them. So as we go over here into our ship edit handler, when we find this component mirror, what we're actually going to do is ask the controller for it. We're going to ask our ship parts controller for it. So get component in parent, ship component list. That's not spelled right. Ship component list. Okay, so what's going on here? Ship component list is in engineering namespace. Well, this should be in the engineering namespace too, actually. We'll deal with that later, though. So get component in parent, ship component list. Boom. So ship component list equals get component. So if not list, debug.log warning, no edited part is not in a ship. Return null. Otherwise, return list.findMirror, and then we want to give it the parent, which is our component. Now that's a little bit more expensive than the alternative, but it doesn't need to have any sort of editing done to make it work on the ship load. Now we have a couple of bugs because we have the stuff we implemented specifically to help with our mirroring that now needs to go away. Boom. Shaboom. Oh, don't need these anymore either. Boom. Perfect. So now that we have done that, we want to delete this fuel cell because it's kind of in the way and try and figure out what we want to do with our ships. So if we were to load up the monkey bars like this, shablooey, we can right click to pull up an editor like so, and then it works. See? Perfect. Bang. Now we've got a problem where the highlighter is a little bit finicky. I think that engine is not a... So what's up with this blue? Is this blue not working? The blue is working fine for these guys. Huh. That's fine. That's fine. This red does not want to trigger, does it? Huh. That's fine. Alright. Looks like we've got a collider issue. Look at that. It's not... It really does not want to click on this red element, does it? What's up with this? Okay, so it's definitely working. It's just not properly highlighting it. You see? So when I click on it, it moves, but it's not actually doing the highlight. Aha! So if I move from a component to that, then when we clear the component, it clears the highlight for the existing object, for the newly highlighted handle. So what we've got to do is make sure that our handle doesn't mix it up. Begin attacker says, is this a crew of clandestine Mexican operatives? I have no idea what that means. So the problem is that our order of operations is screwed up. Here, in our unloaded cursor, when we scan for objects, you can see that here we set the highlighted components equal to null. But that's if there is a highlighted handle. So when we do that, we want to make sure that we don't accidentally clear the highlighter. So our highlighter is in use elsewhere. Do not clear it. That's a hack, though. It's not a very good one either. Yeah, so if we look at the highlighter itself, The only thing that this does is set up our highlighter, so it's okay to skip over it. It's just not a very good... It's kind of stupid. It shouldn't do that. Oh, yeah. Sorry, I was just... The names aren't... There's no randomized names yet. It's pretty low on my list of priorities. So everyone is A to Z. Alice Zorro. I'm going to go ahead and delete this video off of YouTube. Joop. There. So here we are. We got this. We click. There it is. Perfect, right? So there is still something that I want to have happen here. And that is that I want to have it scale to the size of the part. And in order to do that, I need to detect the part and scale immediately. And that means that the reset should happen after I set the location, not before. So because of that, if I look for the instance here, see how I call reset here? We're going to want to move that to after our set parent. Like so. And that way, when it comes up, in fact, we can just put the reset in. Oh, why am I changed? Just put the reset in either way. It should work. All right. So when that happens, what we can do is void awake reset. Thank you. That's exactly how I spell reset. I don't know about the rest of you. So when a component equals null, what we want to do is actually get that component again. We're going to say component transform master equals component. If no master, debug.log warning, editing handles, ship component editing handles are not on a component right now. Now let's take a look back at Twitch so I don't lose track of what's going on. Mr. Idle says, do you allow to object components with rooms inside? Absolutely. Now, when it comes to things like furniture, I'll probably take away 2 of those axes, and you'll only be able to rotate furniture around its own vertical axis. But in terms of rooms, you can certainly rotate the rooms. But the problem with rotating the rooms on any axis other than, keeping them horizontal is that your camera work gets a little finicky. Which is something I'll probably have to deal with at some point. So when we have an object that we're based on, what we actually want to do is get the bounding box of that object. So in order to do that, we're going to just look through the object for the first bounding box we can find, the first collider we can find. If C equals null, then we want to barf. Ship component editing handles could not find a collider. Else, we want to find the bounds of that collider. Bounds B equals, you know what, we should just use some returns. Return. There we are. Bounds B equals C dot bounds. And then what we want to do is get the extents of those bounds. We would just want to get the largest extent. Unfortunately, we don't have a largest extent thing here. We've only got vector 3s. Now, one of the things we could do here is we could get the bounds for all of the composite objects that are making up our collider. But that's a little bit pricey for just an editing purpose, so we're going to just do it this way. So what we're going to do is the extents are all we need. We can also do it with the size twice as large as the extents. That's fine too. So vector 3 size equals b dot. I guess we can just say c dot bounds dot extent or size. There we are. Because that's all we want. And we're just going to find the best one, the biggest one. So float max equals mathf.max size dot x size dot y size dot z, except for we're not going to bother with this. We're going to do it with two very, very basic maths. The reason that I'm not using the arbitrary depth, the arbitrary arguments, is because it allocates memory, and I'd prefer not to have that happen. There we are. So now that our max is in existence, we can set our scale equal to that. So transform.local scale equals vector 3.1 times max divided by 10. Now, when we load up a ship, let's load up the Bjorker for a change. This is one of the ships we have, and what we would like to have happen is for our editing balls to be the right size. You can see that they are roughly the right size. This one is a little bit large. Oh, and look at the highlighter isn't scaled properly, so we'll want to scale it properly, but that's fine too. And this is a little bit small. That one's about right. That one's a little bit large. Why is that one so big? Because of the x-axis. That one is not big enough. Well, it's clear that this is not the right operation we want to use. Float max equals size.x plus size.y plus size.z. Let's try that. Oh wow, it's already been almost 2.5 hours. Going for quite a while. Ah, that's big. That's big. That's big. But it's the right kind of big. Mr. Edel says, I actually thought if you allow them to rotate on all axes, there would be a problem with the rooms connecting. So the rooms connecting is going to be an issue with a lot of... I mean, there's a lot of stuff going on here. If you're using snap together editing, the rooms aren't going to be able to be rotated. You're going to want to... just the doors will automatically snap together. If you rotate them, then when you get close enough to another door, it'll automatically unrotate to the correct rotation so the doors can snap together. And that's already been programmed in several prototypes, so I'm not too worried about it. But it's not currently implemented. So right now, you can just rotate them however you want. But this is more like it. This is the right size for the various rotational objects that I want you to be able to rotate. However, we still have to have this work. And that is not too difficult. We'll just go over here. And in the highlighter, we will set it to also copy the scale, the lossy scale. So that would be here. So here it does actually copy the local scale. We're going to make this the lossy scale instead. Because I don't believe that it's mounted on the same parent, so there's no reason for it to use the same local scale. That doesn't make any damn sense. Oh, lossy scale is read-only? God damn it. The highlighter should be separate, as I understand it. It should just be floating on its own, so its local scale can be the lossy scale of our buddies. Yay, it worked. Hurrah! There's a little bit of finicky. I don't buy. I'll have to figure that out. Oh, I right-clicked on it and it reset the rotation, so that's something. Maybe right-click isn't the right option there. Because these are pretty big. Well, I'll leave it for right-click until I can figure out a better alternative. If you guys have a better alternative, let me know. Yeah, come on, rotate. You can't rotate? Why can't you rotate? So, it's clear there is something going on. It's its own mirror. That's the problem. So over here in our ship component list, when we get the mirror, we're going to want to make sure that it's not us. Ship component mirror equals find mirror.parent. If mirror.transform equals parent, return null. Return mirror. So Jovork says, wow, I just found your YouTube channel 2 days ago and now I found your Twitch by chance. Well, you found my Twitch at the end of my stream. I'm just doing a last minute double check on all the features I implemented and then I'll be done. But you are welcome to download the project. You can find the link somewhere on my Twitch page. And you're also free to join us again because I do this every Wednesday and Saturday at roughly the same time. Yay, I got it to work. Okay, so there's definitely some vibration in how this actually calculates out the angle. I'm not 100% sure that I know why that's happening. You can see that little hiccup? No, see it? Don't really know. I'll have to figure that out. Something wrong with it. But thanks for stopping by, everybody. If you have any last-minute questions, this is literally the last minute. And I am ready to stop. On Saturday, I will be coming by at 3:30 Eastern, which I'm sure is exactly the time period that all of you guys are in. Exact time zone. 2:30 Eastern, that is. But we'll not be working on UI. We'll be working on some real heavy back-end stuff. Unless I do it before then, just because I want to get it out of the way. Won't that be fun? Anyway, if you would like to ask any questions, I'll hang around chat for another 10-15 minutes, and then we're going to be done. Bye. I'm hungry. Yeah, let's go eat.